I want you to imagine yourself in the year 1889, living in the German city of Freiburg in Breisgau. You're going about your day, wandering through the streets, when all of a sudden you're hit by the worst stench you've ever come across. It smells like an impossibly concentrated odor of decaying, rotten eggs. You're instantly overwhelmed with nausea. People around you start vomiting. Some even faint. Where is that foul smell coming from? As it turns out, the source is almost half a mile away. Two chemists, Baumann and Fromm, had performed a reaction that had very unexpected results. Let me give you some context to their work. In the mid-1800s, another German chemist called August Kekulé formulated a theory that would change chemistry forever: the theory of chemical structure. Kekulé proposed a system that described precisely how atoms bond together to form molecules, using simple rules called valency, whereby different elements always form a specific number of bonds in a molecule. Without these rules, it was impossible to know exactly how atoms combined, but Kekulé had provided the framework that allowed chemists to finally visualize the substances they were working with. Now chemistry could be approached with more of an engineer's perspective. Blueprints of compounds could be drawn up to help chemists plan how to construct them. By the late 1800s, a lot of research was going into playing around with the structures of molecules to see what happened. Chemists had become very familiar with loads of functional groups, the parts of molecules that give them characteristic properties and reactions. Many common functional groups contained oxygen, and chemists found that if you swap out the oxygen atom for a sulfur atom, the molecules often became less stable. Pretty much all sulfur chemistry is rather putrid. Sulfur compounds are often given off from rotting and decaying things, so we've evolved to be repulsed by them for obvious reasons. But that didn't deter Baumann and Fromm in 1889 when they began their investigation. They were experimenting with acetone and seeing what would happen if you substituted the oxygen for sulfur to form thioacetone. Acetone has a ketone functional group. Similar reactions had already been performed with molecules that contained the related aldehyde functional group, which looks basically the same as a ketone except that the group is located at the end of the carbon chain. It had been observed previously that the thioaldehydes that formed quickly reacted to form cyclic trimers, which is where there are three molecules bonded together to form a ring. Baumann and Fromm wanted to find out if ketones behaved in a similar way. So, in theory, from acetone, they should be able to form trithioacetone. They bubbled hydrogen sulfide gas, which is essentially a source of sulfur, through a mixture of acetone and concentrated hydrochloric acid, which was added to catalyze the reaction, and watched to see what would happen. Eventually, an oily substance appeared. To separate this off, they steam distilled the reaction mixture. Steam distillation is a much gentler form of distillation, which relies on water vapor carrying molecules through the condenser. This prevents these molecules from getting above the boiling point of water, 100 degrees C, which makes them much less likely to break down. It's the same process that's often used to isolate essential oils from plants. So, the steam distillation should, in theory, separate the trithioacetone from everything else. However, there was something else in that reaction mixture that also distilled the cross. It turned out that some of the thioacetone molecules did not combine to form the trimer. They remained as individual molecules, and they were a lot more volatile, which means they evaporate a lot more easily and hence are a lot easier for the nose to detect. Being highly volatile, much of it escaped and quickly spread through the air, out through the open windows and across the city. Now, despite the chemists in the lab acknowledging that the smell was bad, it was nothing compared to what the people on the street were experiencing. You see, counterintuitively, thioacetone appears to smell significantly worse when it's diluted. This could be because when it's more concentrated, the molecules quickly saturate the receptors in your nose, but if it's diluted, there's more of a regular supply assaulting your olfactory system. Apparently, parts of the city of Freiburg in Breisgau had to be evacuated due to the stench. The following year, in 1890, a German chemist called Julius Lewkowitsch, who was living in England at the time, published a paper describing his own adventure with thioacetone. He'd read the paper published by Baumann and Fromm, describing the pungent chemical that had terrorized Freiburg in Breisgau, and Lewkowitsch had the idea that this compound could be added to the odorless fuel known as water gas, so that it was easier to detect if there was a gas leak. Water gas was made by passing air and steam over hot carbon, giving a flammable mixture of carbon monoxide and hydrogen. So, Lewkowitsch replicated Baumann and Fromm's synthesis of thioacetone. Here's what he said in his publication. There is a very curious analogy between the odorizing properties of this thioacetone and other substances of great scenting power. For instance, otto of roses. Of course, in a very opposite direction as far as the pleasantness is concerned. The pure rose oil has only a faint and perhaps not agreeable smell, but in very dilute solutions the lovely scent is brought out. Similarly, the fearful smell of the thioacetone is brought out when it is diluted with large quantities of air. I had for this a very serious, although at the time a very welcome, confirmation. While distilling the product of the reaction of sulfuretted hydrogen on about 20 grams of acetone, 2 workmen working at the opposite end of the steelworks entered the laboratory complaining of the fearful smell, and declaring that they had been vomiting, felt altogether sick and unable to continue their work. Lewkowitsch ended up recommending a completely different compound to be mixed with water gas, saying the absence of sulfur in it would recommend it all the more. Unsurprisingly, thioacetone hasn't been made much since its discovery. The brilliant Niall Red made a great video where he synthesized some, which I'll link in the description if you want to check it out. I for one will not be attempting it, so thank you Niall Red for your service. Let me know in the comments if there are any other stories you'd like me to make a video about, and if you made it this far, please consider liking and subscribing. It really helps to tell the algorithm that this video is worth watching. Also, if you'd like to support further, check out my Patreon for bonus content. Thanks for watching, and I'll see you in the next one.